Welcome to qnawire.
So a solenoid with 420 turns is 25 centimeters long and has a diameter of 2.5 centimeters. And what we do is we attach a smaller 15-turn coil around the center of the big solenoid. We're told that if the current of the solenoid increases uniformly from 0 to 5 amps over a course of 0.6 seconds, that there'll be an induced EMF in the shorter coil. And our goal is to find this induced EMF. So the first thing that we should note is that the B of the solenoid is given by mu naught times N1, the number of turns in the large solenoid, times I, the current running through that solenoid, over the length of the solenoid. So now we can use the fact that the magnetic flux is given by the magnetic field strength times the area that it's fluxing through, where in our case, A is simply given by pi times r squared, where r is equal to d over 2. So our flux is simply b pi d squared over 4. So now the flux linked with this smaller loop of wire will be proportional to the area of the wire times the number of turns in it. So the flux through this smaller portion will be, I'll call this flux prime. This will be given by N2 times flux B unprimed, where this is equivalent to this expression. So now we can substitute these two equations using the fact that the magnetic field of the solenoid is given by this expression to find that the flux prime is equal to mu naught N1 N2 times pi d squared times the current over 4 times the length of the large solenoid. So we know also that the induced EMF is given by the change in magnetic flux over some unit time. So the flux, which goes like the current, will transition from having a minimum value of 0 to a maximum value, and that value is when the current is maximized at 5 amps. And this happens over the course of 0.6 seconds. So our flux will be from this expression, and our time will be from the amount of time it takes, which is 0.6 seconds. So now all we need to do is plug in values for this. And we find that the magnitude of the induced EMF is given by 1.3 times 10 to the minus 4 volts. So that's our final answer.